Hey guys, we found ourselves in chapter 2, and what we're doing in chapter 2 is a little bit long. It's got a lot of good information. We're going to probably split it up in two in terms of taking a test. So after section 2.5, we're going to take a test, and then we'll take another test after section 2.9 to kind of give you a little bit of a breathing room in terms of studying and preparing materials for this. But chapter 2 is a great chapter, and we're going to start off by looking at writing equations. First thing we're going to look at is our vocabulary word today, which is formula. You guys are familiar with formulas. You use it in science, you use it in math, obviously, use it in a lot of different places. And formula is a rule for the relationship between certain quantities. So formulas that you may be familiar with, let's see if I can get a pen here. Formulas that you may be familiar with would be, I don't know, how about this one? What does this refer to? The area of a triangle is equal to 1/2 base times height, or the perimeter of a rectangle is equal to 2 times the length plus 2 times the width. Or how about a squared plus b squared is equal to c squared, which is the relationship between the sides of a right triangle, where a and b are these sides that create the right angle, and c is the longest side, which is also called the hypotenuse. So we are inundated with formulas all the time. You guys know what they are, and formulas are basically a rule used to relate some quantities together. So let's go ahead and take a look at our first example. So what we're going to do is we're going to translate the sentences into equations. You guys are actually pretty good at this. You've done it before. It says 7 times a number squared is 5 times the difference of k and m. So is a breakpoint in a sense. It tells me where the equal sign is, honestly, because is generally means equal. Because if something is this, then it is equal to that. Does that make sense? Yeah? All right, good. So 7 times a number squared is 5 times the difference of k and m. So 7 times some number, we don't know what that number is, let's call it n. 7 times a number squared is 5 times the difference of k and m. Well, what's the difference between k and m? Difference means to subtract, and when I do 5 times it, I get that. So I'm going to write this a little bit better. 7n squared is equal to the quantity of 5 times k minus m. All right? Let's do another one. So here with number, part B, we've got 15 times a number subtracted by 80 is 25. So there's that is word again. We need to pay attention to it. So 15 times a number, let's call that number n, subtracted by 80 is 15 times the number 15n. When I subtract it from 80, when I subtract 80 from it, pardon me, is going to be equal to 25. And so what we're doing here is we're just taking verbal sentences and we're translating them into algebraic expressions, or equations in this case. All right, here's example 2. We're going to look at this real world example. There are 50 members in the North Carolina Senate. This is 70 fewer than the number in the North Carolina House of Representatives. How many members are there in the North Carolina House of Representatives? So what we'll do is we'll use a variable to represent the number that we don't know. So we're looking for the number of people in the North Carolina House of Representatives. So we're going to call that X. All right. So that's the number of folks in the North Carolina House of Representatives, okay? And so now that we've got that figured out, how can we write an expression? So we recognize that there are 50 members in the North Carolina Senate. This is 70 fewer. This is 70 fewer. So 50 is something. It's 70 fewer than those in the North Carolina House of Representatives. So how can I write that on this side? This number 50 is equal to something. It's equal to X minus 70. So when we say 70 fewer, it says, hey, if I take 70 away, that's what I'm going to get. So we get this expression. To solve it is pretty simple. We're going to, what we do to one side, we're going to do to the other, and X is therefore equal to 120. All right? So we have 120 members of the North Carolina House of Representatives. Here in example 3, we're going to look to translate sentences and translate the sentence into a formula. So it says the area of a triangle equals the product of 1/2 the length of the base and the height. And so therefore, and this is one we already did, so this isn't too bad, we write A is equal to 1/2 base times height. So that's the product there when we look at, this is the product here when we look at B times H that they're speaking of here. Let's look at this next one. In a right triangle, look at this. In a right triangle, the square of the hypotenuse C is equal to the sum of the squares of the measures of the legs A and B. And this is exactly what we had in the beginning. So what they're saying is if we have a right triangle, the square of these legs here is equal to the square of the hypotenuse. And how would I write that? As a squared plus b squared equals c squared. I should have looked more carefully at this to make sure I wasn't giving away answers in the beginning of the problem. All right, so let's take a look at this example 4. We're going to translate each equation into sentences. So here we have 6z, and we're taking away from it 15, and we see that that is equal to 45. So we're going to create a sentence, and every sentence will be different, but the sentence that I'm going to create is the following. So mine is the product of 6 and a number less than 15 is 45. The product of 6 and a number less 15 is 45. So there are a number of ways you could have said it. I even thought about trying to be tricky and saying something like the product of 6 and a number is 15 greater than 45. Do you see how that's actually saying the same thing? It's 15 greater than 45, thus I had to subtract the 15. So there's a number of ways you can say that. Let's take a look at this one. Y squared plus 3x is equal to w. So I would write that like this. Y to the second power plus the product of 3 and another number is equal to w. Y to the second power, or y squared plus the product of 3 and another number, in this case it's x, is equal to w. So that's how I would do it. You may have done it differently, and it's probably okay. Once we generate the same equation, that's what we're looking for. Let's look at example 5. It says write a problem. So we're going to be given some information. We're going to make up our own problem. Write a problem based on the given information. So Beth's salary is P. All right. That's her salary. We see that she gets a bonus, and her bonus is equal to 0.1 times P. What percentage would that be? Seems like, hopefully you guys see that, it's 10%. So she gets 10%. Her bonus comes from 10% of her 10% of what her salary would be, right? And then we see that her salary plus her bonus is now here, and it's going to be $525. So here's what I would do. So Beth's salary and bonus together is $525. That's what I get from this little statement here. If her bonus is 10% of her salary, that just concludes the fact that that's 10%. What is Beth's salary? Remember, if we're creating a problem, we're trying to solve for the variable. In this case, the variable is P. So how would we solve this? Anybody have any ideas? How would we do this? So we have our equation. I know they didn't ask us to it, but I like solving equations, so sue me. So what I'm going to do is I'm going to join like terms together. So I end up with P plus 0.1 P, or a tenth of P, or P tenths. And what I'm going to end up doing is adding this 1 whole plus this 1/10 to get 1.1 times P. In this case, I'm going to set that equal to 525. And I hope that you guys know already we're going to divide both sides by 1.1. And when we do that, what we find is that her approximate salary value is about $477.27, something like that when we divide it out. Okay, so that's how we would do it. Guys, I hope that that was relatively clear. Please do me a favor. Let me know if you have any questions, and I look forward to answering them. I can't wait to see you guys soon. Follow along. Go ahead and do section 2.1 in your packet, and we'll get started looking at 2.2 very soon. I'll talk to you later. Bye-bye.